Hi there, welcome to section 9.2, which is on coordinate, slope, and lines. We're going to continue on with algebra as we're doing in chapter 9. We're doing in this lesson what you would do in an algebra class in probably a month or two. So we're really sort of condensing it down and just touching on the basics. This is not meant to teach, this isn't meant to teach everything from start to finish. This is assuming that everyone has some, background in algebra. So feel free to, let me know, send me an email if, you need some more practice after this video and after doing the homework. So anyway, enough about that. Let's just jump in. So we're going to start just by talking about the coordinate system and then slope of a line. So the coordinate system is just the basic XY coordinate grid, and it's divided into 4 quadrants, and they're labeled in this picture. So you've got quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And the reason we number them is just so that we can talk about, certain lines are in certain quadrants or points. It's just shorthand way of being able to locate lines and points quickly. So now that we've talked about that, let's just jump in and we'll talk about what slope means. So let's start by talking about slope in terms of a ramp that you might see, or a street or a hill. So slope in real life, and then we'll transfer that to how it plays out in a line. So you can look at these pictures. If you think about all of these as like a ramp, for instance, just ask yourself, well, which ramp is steepest? So it's pretty clear that this one to the far right, that would be the steepest. If you were walking up that hill, that would take the most work. The one in the middle would, I would say, take the medium amount of work, and then the one on the left would take the least amount of effort because it's not as steep. All of these ramps are increasing from left to right, and when we have an increase from left to right, we call this a positive slope. So all of these ramps have positive slopes. If a ramp or a line is decreasing from left to right, so it looks like this, we call this a negative slope. And then there's always a number that's associated with the slope. And the number means something other than just being positive and negative. That has meaning, but the actual number can tell you how steep a ramp is. So let's jump in and we'll calculate the slope for all of these, and then we'll look at how those numbers compare to the steepness. So in general, and you may have heard this before, we can say that slope is the rise divided by the run. By rise, it means the vertical change. The run means the horizontal change. So rise over run is just a catchy way of trying to remember it. If that doesn't work for you, you don't have to think of it like that. You can just think of the vertical distance divided by the horizontal. So in this first graph, or this first ramp, we've got a vertical distance. I'll use a different color of 12. So that's going to be your rise. So I'm going to put a 12 there. And then we've got the horizontal distance, which is 100. So 12 divided by 100. And then you can divide those with a calculator to get a decimal, or you can reduce them and leave them as a fraction. Either one would be fine. Like you could divide both of these by 4 and you get 3/25, and you could leave it like that, or you could divide those and get 0.12. So that's the slope of this first ramp. So slope equals 0.12. And then for the second one, we're going to do the same thing. So we're going to take the vertical distance, which is 1, and we're going to take the horizontal distance, which is 3, and we're going to divide those, and we get 1/3. And if we divide those in a calculator, we get 0.33 repeating. And you can see if we compare, so the first slope is 0.12, that's number 1, and the second one is, whoops, I moved my window down here. Okay, there we go. Our second slope is 0.33. So notice that number is bigger. So the ramp that's in the middle is steeper, and it has a larger number for the slope. And that's what you should expect. And then the last one, we'll take the vertical distance, which is 3, and we'll divide it by the horizontal distance, which is 5. And so we get the fraction 3/5, and you could compare those fractions, or just stick that in your calculator. 3 divided by 5, you get 0.6. And so that's the slope. We'll call it number 3. And so if you look at those numbers, the steepest ramp had the biggest slope, and the ramp that was not as steep had the smallest slope. So that's what you can expect for those slope numbers to tell you how steep the graph is. So let's look at graphs here, and we're going to calculate the slope of these graphs. So we're going to do a similar thing to what we just did with the ramp, although you'll notice with these graphs, you don't have this triangular picture of like a ramp in there, but you can actually create it. So one possibility is to just pick 2 points, any 2 points. Now this line actually has 2 points that are identified for you. All of these do. And this is a great way for you to start doing slope. It's just a little bit helpful to have points at first, and then as you get better at it, we can do them where you don't have the points located for you. But it doesn't matter what 2 points you pick on the line. You can pick any 2 points, and then what you can do is you can draw a triangle. And you can draw a triangle below, you could draw a triangle above, it really doesn't matter. And just like we did before, if you want to, I'll even do these in different colors, we've got a horizontal distance and we have a vertical distance. And so we can do rise over run. So the vertical starting from one point going to the other. So actually, you know what we'll do is we'll start at this point right here. And the rise, that's this vertical distance, is 1, 2, 3, 4, 5. But we're going down 5 to get to this next point. So I'm going to do a -5 for run. And then, or rise, I mean, and then run is going to be 1, 2, 3, 4 to the right. On the graph, right is positive, so it's going to be -5/4. If you don't want to deal with the negative and positives when you're counting the rise over run, the other thing you could do is just count the spaces, get 5/4, and then look at this line and ask yourself, should this line be positive or negative, because it's going down from left to right, and you can use this guide up here and you can see that it should be negative. So that slope is -5/4. I'll show you real quick. We're not going to do this for all of them, but if you were to start at this point, you could also rise 1, 2, 3, 4, 5. You could go up 5, which is positive, so that's different than what we did before and going down. And then you go 1, 2, 3, 4 to the left, which is negative. Left is negative, right is positive. And so we still get 5 over -4 is the same thing as -5/4. So you get the same answer. So either way, don't be worried that, you know, you're going to choose the wrong triangle to create or move in the wrong direction. You can start at either point. Okay, so let's do number 2. So number 2, these points are identified for us. We don't have to, you know, use those points. I could pick, you know, there's infinitely many points on the line, and you can pick whichever ones you want. Keep in mind, some are going to be easier to count than others though. So if I were to pick, for instance, like this point right here on the line, it's not on a corner of a box, so it would be tricky to count up and over. So finding points like the ones that we were given here, that's going to make things easier. So we're going to do rise over run. So you can start at either point. So I'm going to start at this first point down here, and I'm going to go up 1. Going up is positive, so up is positive, down is negative for rise. And so I'm going to go up 1, and then I'm going to go to the right 2. So to the right is positive, to the left is negative, so that's going to be a +2. So slope of 1/2, and you can see, just double check at the end, this increases from left to right, so that's a positive slope, and that's confirms that our answer should be positive. So those last 2, these are lines that are a little bit different because they're vertical and horizontal, and these have slopes that you know, are a little bit different than the ones we've been looking at. So let's look at number 3. So we're gonna approach it in the same way. So I'm going to write rise over run. So if I started at, let's say, this point and want to get to the next point, I'm going to rise 2. And I'm not going to run any because I don't need to go left or right. So I've got a 0 in the bottom. Well, you may remember we talked about this before. Well, what happens when you have a 0 in the denominator? This is essentially saying 2 divided by 0. It's not okay. Remember, no. It's not okay to have a 0 in the denominator. It is okay to have a 0 in the numerator. So in this case, since there's a 0 in the denominator, we're going to say that the slope is undefined. And that is true for all vertical lines. So anytime you see a vertical line, it's totally okay to just say the slope is undefined. You don't have to count and actually try to calculate. If you want to, you can, but you don't have to. You can just say the slope is undefined. One thing that I like to tell my students when I taught this in high school and middle school is I always think about what it would be like to be on skis. Well, if I was on skis, think of a vertical line as sort of a vertical hill. And I always say, well, if I were skiing down a vertical hill, completely vertical, I would die, I would fall. So I think of undefined as, you know, as sort of dying on your skis. And then this one, if we think about what it would be like, so if I were on skis and I was completely horizontal, I could imagine that I'm not going very far, so I'm going nowhere. The slope for a horizontal line is 0, and this is how we calculate that. So if I think about my rise over run, if I locate a point, I'm not going to rise any, so that's 0, and I'm going to run, in this case, I would run 1 to the right. 0 divided by any number is 0, so the slope is 0. So we're going to circle that one. There you go. So the slope of horizontal lines is 0, and the slope of vertical lines is undefined. So if you just make a note about that, then you'll be good to go. Oops, and I moved my window again. Let's see. There we go. Okay. So we've got those there. All right, so let me just scroll down here. So we've calculated the slope when we have a line. Now let's talk about how you calculate slope from 2 points. And I'm sure if you've taken, all of you have taken an algebra class at some point, I'm sure. You would have learned about how to calculate slope from 2 points. And when doing that, I would say more often than not, you learn this formula right here. y2 minus y1 over x2 minus x1. And that's assuming that you have these 2 points up here. So this formula works. I'm going to show you an alternate method though that I think even works better. I used to do this with middle schoolers, and I'd find that they would invariably mix up the x's and y's and put them in the wrong spot, and it gets kind of tricky. So I've got another way in addition to this that might help. So keep in mind that, you know, you could pick the one that works for you. So what we're going to do here, it says calculate the slope of the lines above using 2 points on the graph in the formula. So I am going to go to this first graph and I'm going to locate the 2 points on the graph and I'm going to write them down. So this point right here is 0, -1, and this point up here is 1, 2, 3, 4, -4, 1, 2, 3, 4, +4. So we've got 2 points. So -4, 4, that's 1, and then 0, -1. The trick is that instead of labeling them x1, y1, x2, y2, what I do is I just write them on top of each other like this, and I just subtract them on top of each other, and this allows me to sort of visualize this, and then it prevents mistakes from happening, like subtracting in one direction for one variable and the other direction for the other. So this is how you're going to do it. You're going to start with the 4. You're going to do 4 minus -1, which is the same thing as 4 plus 1. And you're going to 4 plus 1 is 5. And then you're going to subtract these numbers and put it on the bottom. So -4 minus 0 is -4. And then you're going to make a fraction. So our answer here, let me write the 5 right over the 4. So our answer is 5 over -4. And that's the same thing we got above, except the negative is in the denominator. Remember that with fractions, you can just move that move that negative sign up because it's the same thing. So let's try the next one. So if we scroll up here, we're going to identify 2 points. So let me erase this line. So we've got the point 0, 0, and then I've got the point 2, 1. And it doesn't matter which one I write first. So 0, 0, and 2, 1. I can put 2, 1 on top, or I can put 0, 0 on top. It doesn't matter. You get the same answer. So I always subtract the y's first. So 0 minus 1, -1. And then I'm going to do this one, 0 minus 2, So negative 2. So I get negative 1 divided by negative 2. A negative divided by a negative is a positive 1/2. So the slope here is 1/2. And you know, it just got me thinking. One other thing to remember that's helpful is if you remember the saying, wise up, like you better wise up, you can think of y is up, meaning the change in y is on the top and the change in x is on the bottom. So when you're subtracting, you're always subtracting the y numbers first, and that's going on the top. So let's do the next one. So with the third graph, we had 2 points. We have 0, -2, and we have 0, -4. So I'm going to write them on top of each other. Whoops. That should be a 4. There we go. And now I'm going to subtract. I subtract the y's first. So -2 minus -4 is -2 plus 4. So -2 plus 4 is 2. 0 minus 0 is 0. And we don't want a 0 on the bottom, so we say the slope is undefined. So that supports our answer from before. And then this last one, whoops, I just erased all that. There we go. Okay, and then this last one, I've got 2 points. So 2, -1, and then 1, 2, 3, -1. So 2, -1, 3, -1, and then I subtract. So I subtract the y's first. So -1 minus a -1 is -1 plus 1. So I get a 0 on the top. 2 minus 3 is -1. 0 divided by -1 is just 0, so the slope is 0. So you've seen how to do it visually, and now you've got the algebraic way to do the slope. All right, and then let's just try this example. So this is a good place for you to just check your knowledge. So if you wanted to pause the video and try these, and you could do these by counting and looking at the picture. You could also do these by identifying 2 points on the graph and then doing the algebraic way. It's totally up to you. So I'm gonna, for this first one, I'm gonna locate 2 points that are easily identified. So maybe like right here is 1, 2, 3, 4, 1, 2, 3, so 4, 3. So there's 1 point. And then it looks like this would be a good point here. So 1, -1. And I'm going to do it by counting. So I'm going to remember that slope is rise over run, which just means the change. This triangle means change in y over change in x, okay? So up is positive, down is negative, right is positive, left is negative. So I'm going to draw a triangle and I'm going to count 1, 2, 3, 4. So I go up 4 and over 1, 2, 3. So my slope here is 4/3, and then I just double check that the line should be positive, and it should because it's going up from left to right. Okay, this next one, I've got a horizontal line. Horizontal lines have slope of 0. Okay, this third one, I'm going to locate some points. So that point looks like a good one. So -1, 1, 2, 3, 4. So I got -1, 4. And then let's see. You know, it's hard to sometimes get the exact, maybe like right there. Looks pretty good. 1, 2, 3, 4. 1, 2, 3, 4. So 4, -4. So if I count here, I'm going to go down 1, 2, 3, 4, 5, 6, 7, 8. So I go down 8. To the right, 1, 2, 3, 4, 5. So I get a slope of -8/5. Now, if you did this and you picked a different point, you know, maybe you picked the point like right here because that looks like it's on the box, you're going to get a slightly different slope. That's totally okay. I would not worry about that. I mean, it's really, we're eyeballing it here, and depending on your eyes, you might pick a different point and get a slightly different slope, and that's okay. And then for this last one, it's vertical, so we say the slope is undefined. And if you want to go ahead and do the algebra with that, you can. So now that we talked about slope, we're ready to talk about equations. So one equation, and I'm sure you might remember this from algebra, is called the slope-intercept form of a line. And we say the slope-intercept, we call it y equals mx plus b. M and b are constants. Constants, that just means they are numbers. So for example, if you have the equation y equals 4x plus 5. So m is always a number, b is always a number, and then the x and y always stay x and y. The 4 is going to be the slope, and the 5 is going to be the y-intercept, which is the place that it crosses the y-axis. So that would mean it'd cross at 5, and it would look like that. So let's write the equations for these lines. So we're going to try to identify the slope and the y-intercept. So the y-axis is this vertical axis. We're going to see where it crosses. So the y-intercept for this first one, we're going to say b equals -2 because it crosses at -2. And then let's just use that point and find one other point that we can find the slope. So maybe like right there. And so I'm going to start at this y-intercept point and I'm going to rise over run. So I'm going to go up 1, 2, 3, 4. So +4 to the left 1, 2, -2. And if you reduce that, you end up getting -2 as the slope. And then always just double check, ask yourself, well, does the line look like it has a negative slope? And it does because it decreases from left to right. So my equation is going to be y equals -2, because that was my slope, x, and then plus a -2, or you can do -2, either one. Okay, this next one, so the horizontal one and the vertical one that we'll do last, these ones are a little bit different in terms of the equations. So anytime you have a horizontal line, if you think about all the points that are on that line and what they have in common. So every single one of these points, we could write them down. There's infinitely many points, but let's kind of talk about a couple of these. Like, what's this point right here? It looks like it's 0, -1. And this point right here is 1, -1. And this point right here is 2, -1, and then 3, -1, 4, -1, 5, -1. Do you notice something in common? All of the y values for all of the points on this line are all -1, and that's because it crosses through y equals -1. So horizontal lines in general are always going to be written as y equals whatever number they cross the y-axis at. So let me just erase all this so we can see the line. So here's our line, and it crosses at -1 on the y-axis. So for this equation, we're just going to write y equals -1. So where they cross y-axis, okay? So the equation is y equals -1. So it's not in, you could say this is in y equals mxb form. It's just saying that the slope is 0. So that's another way to look at it. Y equals m. So the slope is 0 because it's horizontal. X plus the y-intercept of -1. Well, 0 times anything is 0. So then you end up just getting y equals -1. So let's look at this next one. So it looks like the y-intercept is -1. So I'm going to say b equals -1, and then I'm going to identify another point. Looks like there's a good one right there. So let's look at the slope. So starting at this point, we're going to go up 2, +2, and to the right 1, 2, 3, 4, 5. So it looks like I have a slope of 2/5. So then we're going to put that all together. Y equals 2/5 x minus 1, or plus a -1. And then lastly, we have this vertical line. So remember, vertical lines have an undefined slope. So if you think about y equals mx plus b, what does that look like to just have an undefined slope? You can't plug in undefined. So we're going to look at this in a different way. So similar to the horizontal one, let's look at all the different points and see, what do these have in common? So every single point on this line has a common value. So this point right here is 1, 2, 3, -3, 0. This one is -3, 1, -3, 2, -3, 3, -3, 4, -3, 5. Every single point on this line has an x value of -3 because it crosses the x at -3. So the equation is x equals -3. So vertical lines always have equations that are x equals some number, and the number is where the line crosses the x-axis. Okay, so let's try example 3. So write the equation of the line through the given point and with the given slope, and then sketch the graph. So these we're adding on here. They're similar, but we're getting a little bit more difficult as we're going through these. So let's look at this first one. We're trying to find a line that goes through point 2, 1 and has a slope of 7. We're asked to sketch the graph. So let's find point 2, 1 on the graph. So that means over 2, up 1. So it'd be right there. And then a slope of 7 means we're going to rise 7 and go over to the right 1, because 7 is the same thing as 7 over 1. So I'm going to start at my point. Oh, and it looks like it got erased there. There we go. So 2, 1, and I'm going to go up 1, 2, 3, 4, 5, 6, 7, and then over 1. And you can keep doing that. The problem is if we go up 7 again, whoops, I erased it again. 1, 2, 3, 4, 5, 6, 7, and over 1. If we do it again, then we're going to be off the graph. So I'm not going to go up and over again. But what we can do is we can go opposite, and we can go down 7 to the left one, which would be like -7 over -1, which reduces to 7 over 1. So I'm going to go down 1, 2, 3, 4, 5, 6, 7 over 1. And then you can use a straight edge, and if you use a straight edge, you can connect those points. I don't have a straight edge tool on the computer here, but you can imagine what that would look like if it was straight. So algebraically, let's go through and find the y-intercept in the slope. So slope-intercept form is y, oh, it looks like I'm freezing up here. So slope-intercept is y equals mx plus b, and so our goal here is to find the slope and the y-intercept. And looking at the graph, we can estimate, it looks like the y-intercept might be around -10, but we want to actually use algebra to find out exactly what it is. So the first thing we're going to do is we're going to plug our point in. So the 2 is our x coordinate, the 1 is our y coordinate, and then the slope 7, that's going to be our m. So we're looking at plugging in numbers for the y, the m, and the x, and then that will leave b all by itself to be solved for. So the y is 1, so instead of y I'm going to write 1. The m is 7, that's our slope. X is 2. And then plus b. And then when we have numbers for all variables except 1, we can solve for the one that we're looking for. So to solve for b, I'm going to subtract 14 from both sides, and I'm left with -13 equals b. So earlier I said it looks like the y-intercept is about -10. You can see it's great I used algebra because I was wrong. I mean, the graph is good to eyeball it, but it's not as accurate. So the slope, or the y-intercept, is -3 or 13, and we already know the slope is 7, so now we can write our equation. So our equation is going to be y equals 7x, 7 because 7 is the slope, plus -13. So that's the answer. So we're going to do the same thing for the next one. So the next one I'm going to locate, and you could pause the video here and try these. Next two would be a great place to pause. So I'm going to locate 3, 5. So 1, 2, 3, 1, 2, 3, 4, 5. And then I'm going to go use the slope of 5, 3. So I'm going to go up 5 to the right 3. So 1, 2, 3, 1, 2, 3, 4, 5, 1, 2, 3. And I can't go any more because I'll be off the grid. So I'm going to start at my 0.35, and I'm going to go down 5, 1, 2, 3, 4, 5, and to the left 3, 1, 2, 3, because going down 5 is -5 and left is negative, and a negative divided by negative is a positive. So then I could do it again, -1, 2, 3, 4, 5, 1, 2, 3. Now, and you could keep going if you wanted to, and then use a straight edge to connect. Now this one looks like I have a y-intercept of 0. Let's use algebra to see if I'm right. So I'm going to write down y equals mx plus b, and then I've got an x value of 3, a y value of 5, and a slope of 5/3. So I'm going to say 5 equals 5/3 times x, which is 3. I'm going to write that 3 over 1 so that it makes multiplying easier with the fractions, plus b. Now there's a 3 on the diagonal here, so those 3 we can cross cancel, and then you're left with 5 equals 5 times 1, or 5 plus b, and then subtract 5 from both sides, and we end up getting b equals 0. So that's what we see on our graph. I'll use a different color. We see that here's the y-axis. We see that that line crosses the y-axis at 0. And then we already know the slope is 5/3, so we can write our equation. So y equals 5/3 x plus 0, or you can just say y equals 5/3 x. You don't even need to write the 0 there. So that's our equation for that one. And then the last one, notice I don't have the slope on this one. So the first thing I'm going to need to do for this one, well, I could plot both of those points. So I could plot 2, 3, and then 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6. And then you could use a straight edge to connect those. Looks like my y-intercept is going to be around maybe 2, but I'm just eyeballing it, so let's use algebra to double check. So with my equation y equals mx plus b, I need an x, which I have, a y, which I have, and then I need a slope, which I don't have yet. Now, we have 2 points, so we can find the slope. So step 1 is going to be to find the slope. So I'm going to do that by writing these vertically on top of each other, and I'm going to subtract them, just like I did in a previous example. So 3 minus 6 is negative 3, that goes on top. Y always goes on top. And then 2 minus 8 is negative 4. And then if I reduce this, a negative divided by negative is a positive 3/4. And then just to double check, I could have used the graph too. We go up 1, 2, 3, and over 1, 2, 3, 4. Oh, and you know what? It looks like I must have plotted that wrong, because if we go up 1, 2, 3, and 1, 2, 3, 4, we're not at that point yet. So let me just double check that I did this right. So we've got 8, 6, and 2, 3. That looks good. I must have plotted these. Let's double check. 1, 2, 1, 2, 3. That looks good. And then 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6. Let me see here. Oh, I see where my mistake is. 2 minus 8 is not negative 4. Whoops, it's negative 6. And this is why it's great to do this both with algebra and then visually, because we can check our work. So 3 divided by 6 is 1/2. So let's just double check that again. If we use that slope here, we go up 1 over 2, up 1 over 2, up 1 over 2, and that works. Awesome. Okay, so we got 1/2, that's equal to our slope. And then let's go ahead and I'm going to find the y-intercept. So I'm going to use y equals mx plus b. Come down here at the bottom, and I'm going to use one of my points. It does not matter which one. I'm just going to pick 2, 3. Okay, 2 is going to be my x, 3 is going to be my y. So y is 3, my slope is 1/2, x is 2, or 2 over 1, plus b. The 2's end up canceling out with the fraction, so you end up getting 3 equals 1 plus b. Take away 1 from both sides, and you end up getting b equals 2. And it looks like, from the graph, it looks like it crosses at 2 anyway, so that's a nice confirmation there. So our final answer is going to be y equals our slope 1/2 x plus 2. So y equals 1/2 x plus 2. Okay, so let's go down to the next section. So the next section, we're going to expand on this a little bit, and we're going to talk about parallel and perpendicular lines. So this is a picture from our textbook that I copied to our notes, and it shows the different equations for lines that are parallel and perpendicular. So let's look at some of the parallel lines. So look at these lines that are going in this direction, and look at the equation. So this one over here on the right, this line right here, has an equation y equals 2x minus 4. This one right here, y equals 2x minus 2. This one is y equals 2x. Y equals 2x plus 2. Y equals 2x plus 4. Do you notice something similar with all of those equations? Similarly, if you were to look at these lines that are all parallel. Look at those equations. See if you can figure what's similar about those. Those all have the same slope of -1/2. These equations all have the same slope of 2. So the slopes of parallel lines are the same or equal. Okay, now let's look at the differences between the slopes of the parallel or the lines that are perpendicular. So check out the slopes of all the blue lines. Those all have slopes of -1/2. And then I'm going to use a different color. I'll use red. These lines that are perpendicular to the blue ones all have slopes of 2. Well, what do you notice about the numbers -1/2 and 2? So what's the relationship between those numbers? Well, they're different signs. One's negative and one's positive. So the slopes of perpendicular lines are opposite, meaning the signs are different. And then they're also flipped. So -1/2 and 2, not 2 over 2, I meant 2 over 1. See how these numbers are the same, but they're just flipped? That's called the reciprocal. So if you change the sign or opposite and take the reciprocal, which means flip, so opposite means change sign, then you've got the slopes of perpendicular lines. So let's do an example. So write the equation of the line described through point 42 and parallel to y equals -3/4 x minus 5. The only reason why we need this last part is we need to look at this slope. That's it. We don't care about the y-intercept of this other line. We just know that the line we're trying to find is parallel to this one. So if it's parallel to this one, it means that it has the exact same slope. So if the line that we're trying to find has the same slope as this line, it means the line we're trying to find has a slope of -3/4. So I'm freezing up here. Let me see if I can fix this real quick. Okay, that's better. So I'm going to write down slope equals -3/4. Now I'm done with that line. I don't even need it anymore. So now I've got the information that I need to find the equation of a line. So this now is the exact same type of example that we did before. So we can write y equals mx plus b. And then we can plug in x is going to be 4, y is 2, and then we'll plug in our slope. So 2 equals -3/4 times 4, or 4 over 1, plus b. The 4's on the diagonal end up cross-canceling, so then you're left with -3 there. So we've got 2 equals -3 plus b. I'm going to add 3 to both sides to get b by itself, and you end up getting b is 5. So our y-intercept is 5, our slope is -3/4. So now I'm going to write my equation, because that's what I was asked to write an equation of the line described. So the answer is going to be y equals -3/4 x plus 5. Okay, so let's try the next one. So the next one is very similar. So this would be a good place to pause the video and try it on your own. So the next one, we've got a line going through -1, 4. So we've got an x value and a y value. If it's parallel to this line right here, let's look at the slope. The slope of this line is -5. So that means the slope of the line we're trying to find is also -5. So once I pull that slope from that line, I don't even need that line anymore. So I know that the slope is 5. I'm going to rewrite this since it's hard to see. 5, there we go. And so I'm going to write y equals mx plus b, and I'm going to plug in 4 for y, -5 for x, -1 for, or -5 for m, sorry, -1 for x, and then I'm going to solve for b. So we've got 5 plus b, take away 5 from both sides, and you're left with b equals -1. And then I just write my equation. So my slope, -5x, plus my y-intercept of 1. And if we just double check, if we look at this equation that we found, it's parallel to this one because they both have slopes of -5. Now we're going to do 2 other examples. These ones are perpendicular examples. So the only thing we need to do is that's different is we need to identify the slope here, which is -2/7. If the line we're trying to find is perpendicular to this one, then the slope is going to be the opposite, so it's not going to be negative, and then it's going to be the reciprocal, so 7/2. So I flip it, and then I remove the negative sign. And then I go through my steps like I did before. So I've got an x and a y. So 4 equals 7 halves x is 2 plus b. The 2's end up canceling and you get 4 equals 7 plus b. Take away 7 from both sides and you get b is equal to -3. And then my equation is y equals 7 halves x minus 3. Okay, last one. So this is a good example because if we try to identify the slope here, notice there isn't a number in front of the x, but you do see a minus there. So basically what this means is it's kind of like there's an invisible -1 there. So if this slope is -1, then the slope of the line that we're trying to find is going to be the opposite reciprocal. So it's going to be positive. And then if we flip 1 over 1, we still get 1. So the slope of the line we're trying to find is 1. So 1 and -1 are opposite reciprocals. So I'm going to write down y equals mx plus b. I'm going to plug in my y of 0, my slope of 1, x is 5, and then I'm going to solve for b. So 1 times 5 is 5. I take away 5 from both sides, and I get b equals -5. And then my answer is just going to be our slope of 1, so 1x plus -5 or -5. You can write it either way. And then the 1 does not have to be there. You can just write it x minus 5 would be okay too. So either one of these, we'll just say or, are both okay. So we couldn't do an algebra section without doing a couple story problem. So that's what this next part has to do with. So in example 5, we got 2 types of lawn mowing businesses, and they have each started a fierce ad campaign to gain more lawn mowing business. Let's look at both of these. We're going to write an algebraic equation to represent the cost of each business, letting x represent the number of hours and y is the cost. So that's important to identify. So x equals hours, y equals cost. So for this first one, Deluxe, they charge $12 per hour. So per hour, or a rate, is we're going to use times. So we're going to say the cost, y, is going to be $12 per hour times x. And it says no startup charge, so plus nothing, that's it. So y equals $12 per hour. So we're done with that one. For the lawn styling business, the cost, y, is, so is means equals, $11.50 per hour. So you might think, oh, that's a great deal because it's less per hour than the other company. But, whoops, that's erasing everything here. There we go, $11.50x, but there's a $10 startup fee. So we're going to say plus $10. So we're basically going to use these equations to compare these two businesses. So B says use the method of substitution to determine the number of hours mowing where the two businesses charge the same amount for the month of April. So we're only looking at 1 month. What is the amount they charge for this many hours of lawn mowing? So what substitution means is you basically, what you're going to do is you're going to look at these and you're going to say, okay, well, if y is equal to 12x and y is also equal to 1150x plus 10, then I can set these two equal to each other. And so basically I'm substituting this y in for that one. So we can say 12x equals 1150x plus 10. And then we're going to see, well, what x is this, or number of hours are these actually equal? So we're going to solve this equation for x. I'm going to get x together by subtracting 1150x from both sides. So 12 minus 1150 is 50 cents times x equals 10. And then we're going to divide both sides by 50 cents. So you can ask yourself, how many times does 50 cents go into $10? You end up getting 20. And then remember, x is the number of hours. So that means for 20 hours of lawn mowing, they charge the same exact price. And we can figure out the price by just plugging in 20. If I do 12 times 20, then I end up getting $240. I could plug 20 into the other equation, and you should get the same price, and you do. You end up getting $240. So at 10 hours of lawn cutting, they end up costing the same. Now, this doesn't ask, but you could even figure out at this point if we look at the graph. So if we think about what the graph would look like. So deluxe has a y-intercept of 0, and it's got a slope of 12x. So I'm just going to estimate here and do a sketch. So we'll call this deluxe. And then for lawn styling, it has a y-intercept of $10. So we'll say that's 10. I'm going to use a different color. The slope is not as high, so it means that it's not going to be as steep as the deluxe one. Okay, and they've got this point where they're equal, and that point is 20. So you can look at the graph and see that if you are going to need less than 20 hours of cutting, the deluxe company is going to be cheaper because the deluxe company is lower. So the deluxe at this point is cheaper, and the lawn styling is more expensive. Now after 20 hours, you can see the red line ends up being below. The red line, or the deluxe, or I'm sorry, lawn styling ends up being cheaper after the 20 hours. So that 20 hours is like what we call the break-even point. For example 6, so let's look at these. The Spanish Club has decided to open a competing lemonade stand at the school fair. Their presidents presented the fair organizers with the following profit equation. So I'm just going to write Spanish 4 equals 110C minus 2P. And then it says, will the Spanish Club make more or less than the Math Club? So I'm going to write down Math, if their equation is P equals 0.55C minus 2, where C equals number of cups and P equals profit. It's really hard to compare these two equations when they're written differently. One of them is solved for P, the other one is not. There's a variety of ways that you could solve this problem. But one way that you could approach this is just to get both of them. Since the math is solved for P, what we could do is we could solve the Spanish for P and see how they compare. So let's take Spanish. I'm going to come down here and I'm going to solve that for P. So I'm going to take this, I'm going to just write it down again, and I'm going to add 2P to both sides. So 2P plus 4 equals 110C. And then I'm going to subtract 4 from both sides. I get 2P equals 110C minus 4. And then I'm going to divide both sides, divide everything by 2. And when I do that, I end up getting P equals 0.55C minus 2. So that's my equation for math, and then that's my equation for Spanish. And then up here, I've got my equation for math. And if you look at those, they actually end up being the exact same equation. So they're going to have the same profit because they are the exact same equation. Sometimes it's deceiving because the equations can be written in different ways and they look different, but in this case it's not. Now if you wanted to, we could graph this. We could say, okay, it's got a y-intercept of 2 and a profit or a slope of 0.55 over 1. So that'd be like up 55 cents over 1, up another 55 cents over 1, kind of like that. And I'm just sketching this real quick. It's not an exact line. And let's do one more. So example 7, this is similar. We've got the Logic Club. So they have an equation of 4P equals 2C minus 5. And then we've got the Chess. Just do them next to each other. The Chess is P equals 0.5C minus 1.5. So same as the last one, it's really hard to compare because they're both not solved for P. So what I'd like to do is solve this logic equation by P by dividing everything by 4. And when you divide by 4, you could write it like this, but actually I'm going to write it so that both of these terms are being divided by 4 because that's what we're going to have to do. So we're going to get P equals 2 divided by 4 is 1/2 or 0.5C, and then negative 5/4 is going to be the y-intercept. So I've got 0.5C minus 5/4, that's my one equation for logic, and then 0.5c minus 1/2. Now I'm noticing, and you may notice as well, maybe not, but notice in both of these equations that they have the same slope. What did we talk about on the previous page? What are they going to look like if they have the same slope? They're going to be parallel. So they're never going to cross. So if you graph this first one, we'll graph logic in blue. So for the logic equation, I'm going to say negative 5/4 is the same thing as negative 1.25. So that'd be down 1 and a little bit more. And then we're going to go up 50 cents over 1, up 50 cents over 1. Okay, so we've got this line. Okay, so this is logic. And then I've got chess. I'll do chess in green, if my green pen works here. So chess is going to be green. And then I've got a slope of negative 1.5, so it's slightly, or not slope, y-intercept slightly less, and it's the same slope. So it means it's going to just go right next to this one, and this is going to be chess. So you can see they never cross. So now we can look at these pictures though and ask ourselves the question, which one is going to have the greater profit? And you can look at the lines, and the line that's further vertically in the positive direction, so the one that's above, so in this case the logic, is going to be more profitable. So logic will always make more money because we'll just say it's above the chess and the chess line. And if the visual is not doing it for you, the other thing you can do is you can look at, they have the same slopes, but check out the y-intercepts. So if logic is starting in the hole $1.25, yet chess is starting, we could say starting in the red or in the hole of $1.50, then it means that chess is always going to be behind because they started in the more negative. And one explanation for this might be that they had to buy things in order to start their lemonade stand. So they had to spend some money, and you know, realistically, in today's day and age, you probably spend more than $1.50 and $1.25, but who knows? Maybe they got donations. And so maybe the chess club had to spend $1.50 on some cups or some lemonade, and Logic had to spend $1.25 before they started. And so since chess spent more money to begin with, they're going to always make, in the end, they're always going to make less than Logic would, but they're very close. So that's it for this section. As always, if you have any questions, definitely send me an email and let me know, and I'd be happy to help.